Now we will discuss. Till now we discuss about the implementation of ANN using Python from the scratch. We write every code. Now I want to use the libraries that are available with the Python to build the ANN model. So one of the famous library available with Python is called a Keras. So using this Keras library, I want to build the ANN for our real-time problem that is called electric power load forecasting on a substation, 33 by 11 kV substation. As I said earlier, don't confuse about the terminology, electrical power, load, substation, electric substation. If you are not an electrical people, forget about that terminology. Just you see the load values in terms of some numbers, that's it. We already have a data. So as I said, my data is available in the form of .csv extension in the drive. And I will use that data to train my ANN model. And later I will use that ANN for the predictions. Now coming to the required libraries, import NumPy for the array operations, import matplotlib pyplot. This is for the to draw the figures. Now import Keras. So Keras is a deep learning. Keras is a deep learning library that helps you to code deep neural networks with fewer lines of code. With the fewer lines of code, you can build the deep neural network. You can build the deep neural network. Now, from Keras library, you have to take models. Which model you want to take? Sequential model. Why sequential model? Because you have the input layer, hidden layer 1, hidden layer 2, hidden layer 3, and output layer. All the layers will be sequentially coming one by one. So that's why you take the sequential models. If you observe our architecture, here, you can see our DNN model. You have the input layer connected to the hidden layer connected to the output layer. This is called the sequential architecture. So that's why we are taking the sequential model. And the Keras dot layers import dense. So these layers are called as the input layer, hidden layer, output layer, are also called as the dense layers. So that's why we have to take the dense layers. And in the previous code, I said that we are using the gradient descent optimizer. So various types of gradient optimizers are available like RMS prop, odd delta, SGD, odd gradient, odd. In this workshop, we are not going to discuss about the mathematics behind all these optimizers. But what code we write previously, what we discussed in the last day 2, day 3, and day 5, that is the SGD, stochastic gradient descent optimizer. For that case, we are writing our own code. Now we are using SGD. That's it. Everything will be done in the backend. We don't know the Python Keras libraries, everything available, and everything will be available in the Keras library. Understood, right? So actually, on day 2 and day 3 and day 5 first session, we write the code based on the stochastic gradient descent optimizer. Now I want you the same stochastic gradient descent optimizer as a function. All the code will be available in the backend in the Keras library. I'm not writing the code now. Okay. So I want to use the SGD and import pandas. This is used for the data manipulation. Okay. Now as usual, this piece of code we already discussed it. I want to take the real-time load data on a 33 by 11 kV substation available in the CSV file and read this data and assign to this variable. So this is completed. Now I want to normalize the data. So because my original values are, if you observe, we will see the load data. Original values are 5551 like that, right? Total 2184 rows. 2184 rows. Okay. So original values are 5551, 4983 like that. But I want to normalize the data to make between the 0 to 1. Simply use the min-max scalar. This part we discussed in the previous session. Okay. Now this is about the data pre-processing because I want to actually my data is available like a column. My data is available like a single column. But my approach is I want to predict the load at a particular time based on the last 3 hours load data and also based on the last 3 days load data. That means total 6 inputs and 1 output. we have to rearrange the data accordingly. So to rearrange the data accordingly, I am writing this piece of code. So what is this one? See. So this is the K is the, I want to predict the load at time K based on the K minus 1 hour before, K minus 2 hours before, K minus 3 hours before, K minus 24 1 day before, K minus 48 2 days before, K minus 72 3 days before. So I want to process the data. Actually, the column matrix, I want to make it as a two-dimensional matrix. After doing all the things, now you can use the data split. I'm going from other approach. Whatever the data is available, that is like a matrix or array. I want to convert this whole data as a data frame. So to convert the whole data, load data process, whole data, load data process into the data frame, you have to use this line. So data set equal to pandas pd.data frame and convert this data into a data frame. So this is the data frame. Now in this data frame, if you want to see whole data, you can see the data, whole data also. This is my data set. This is my data set. In this data set, column 1, column 2, column 3, column 4, column 5, column 6. These are the input features. And last column, index 6 column or 7th column is called as the index 6th column or column number 7 is called as output. So I want to split input data and also output data. So input data means 0 to 5. So that's why I'm writing the 0 to 6, but last value is excluded. That means it will count from the 0 to 5 only. 0, 1, 2, 3, 4, 5, up to 0 to 5 only. Those values will be stored with X inputs. And output is in the last column, 6th column. So that's the last column, 6th column. That will be stored in Y. So X means inputs and Y means outputs. That is available now. Now what I am to do is I want to split the data for the training and testing purpose. So in previous exercises, I am passing for the train underscore test underscore split method. Just I pass the whole data set. I'm not splitting the input and output. I'm passing the whole data set. But now I am passing the input data and output data. Now this input data is splitted for the training and testing. X train is the input data for the training. X test is the input data for the testing. Similarly, this output data also split for the training and also for the testing. This is what I am doing here. This train split method want to split this input data and output data for the training and also for the testing. And the 0.2 represents the 20% of the data I want to use for the testing, and the remaining 80% of data I want to use for the train. So this is how we have split the data. Right? Now let's discuss about how to build the model. How to build the model. So just give me time. I will explain here. Now we know that there is a 6 input features in the neural network model. So this is called as the K minus 1 hour before, 2 hours before, 3 hours before, and this is the 1 day before, 24 hours before, and 2 days before, 48 hours before, and 3 days before, 72 hours before, and one output neuron to predict the load at particular time t. In between, I want to use one hidden layer, let us assume. With hidden layer of 32 neurons, let us assume I want to use the hidden layer of 32 neurons. How to build this type of neural network that you can see here. So if you want to build this model using the Keras library, then what you have to do is first, you have to initialize your model equal to sequential. So you have to initialize that model. You have to initialize sequential model. Okay. Why? I think I didn't run the libraries. This part I didn't run. That's why it's coming like this. So this part I didn't run earlier. That's why it's showing that error, that case. Now it will come. Model, sequential model. Done. Okay. Now I want to use only one hidden layer, right? Now what we have to do is model dot add. For this model, you have to add one hidden layer. Hidden layer means dense layer. You have to add dense layer. DENSE, dense layer. How many neurons you want to keep? Let's assume I want to keep the 16 or 32 neurons or 16 neurons. I want to keep 16 neurons. I want to keep 16 neurons in this hidden layer. So 16 neurons is under the dense. You have to pass 16, comma. And which activation function you want to use here? Let's assume I want to use sigmoid activation function in every neuron. So then what we have to do? So activation equal to sigmoid. So activation equal to sigmoid. So this is my hidden layer. So hidden layer has a 16 neurons and activation equal to sigmoid, and keep comma. Now for this hidden layer, what will be the input? So what will be the input? So for this hidden layer, my input is six value array, a array of size 6 values. That's what I have to pass as the input shape. You have to pass as a input shape. Sorry, you have to pass as a input shape, comma. So you have to pass number of hidden neurons. You have to pass which activation function. You have to pass your input shape. So what is the input shape? Input underscore shape of. So it is a 6 value array. Why 6 value? 1 hour before, 2 hours before, 3 hours before, 1 day before, 2 hours days before, 3 days before. Total 6 inputs are there. That's why 6 comma you have to keep. Any mistake? Sorry, input underscore shape equal to. Input underscore shape equal to 6 comma. That means because we have the 6 inputs, we have to use 6 comma. So now, so this is completed. Input shape 6 and completed 16. Now what we have to add? We have to add one output layer. So output layer also like a dense layer you can take. You have to add model dot add dense of how many neurons in the output layer? Last layer only one. So 1 comma. What activation function you want to use? Activation. You want to use activation equal to sigmoid. Activation equal to sigmoid. Sorry, sigmoid. That's it. So this is my model that's visible here, right? This is my model. So this model has a one input layer of 6 neurons, one hidden layer of a 16 neurons, and on output layer 1 neuron. So you can run this cell. If you want to see the model summary, you can write model dot summary. So it will give the information about the model. Complete information about the model it will provide. Provide the complete information about the model. So any idea why it is a 112 parameters, why it is a 17 parameters? Because if you observe here we have the 6 input neurons. Here we have the 16 hidden neurons. Here we have the 1 output neuron. What will be the size of the weight matrix Wij? So Wij weight matrix between the input and hidden is 6 into 16. These are the weights. And what about the biases? How many biases will be there? 16. So what is the total value? 16 into 6, it is the 96. And it is the 16. Then we have the 12, 112. So this is what? 112. And why? Next, coming to this part, Wjk, the weights between the hidden layer and output layer. So Wjk, that's equal to, here we have the 16 neurons and the output layer has only 1 neuron, that is equal to 16. And what about the Bk? How many Bias parameters will be there in the output side because we have the only one neuron. So we have the only one bias parameter, total 17. So that is what 17 here. So sum of these two, 112 plus 17, total 129 parameters will be there in your model. That's what 129 parameters. So this model took 516 bytes of memory in your computer. It took the 516 bytes of memory to store this simple model. So like that, we can initialize our model. Once the model initialization is completed, now what is the text? You have to write the compile. You have to compile your model. You have to compile your model. How we compile the model? You can write model.compile, 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 and which loss function we are using for the ANN. You can see which loss function we are using for the ANN till now. Which loss function we are using? This one. This is called the mean square error. So the loss function which I want to use, MSE, mean square error. And till now we are using all these derivation based on the stochastic gradient descent optimizer. So that I want to use SGD, stochastic gradient descent optimizer. Optimizer is a stochastic gradient descent optimizer. You no need to write the complete code, complete algorithm. Simply call SGD. That's enough. Metrics. Metrics means what error you want to consider to observe the performance of your model. So what thing we are using till now? Mean square error, right? In error calculation also, if you observe here, in error calculations also, where it is? You observe here, error computation, what error we are using? Mean squared error. That we are writing, but you can call that mean squared error here from the Keras library. So you can see here. So I want to use under the model.compile, you have to provide which loss function you want to use to update the weight parameter. I want to use the mean square error. Which optimization technique you want to use? I want to use the SGD, stochastic gradient. And which metrics you want to use to observe the performance of the model, that is the MSE, mean square error. So that is the model.compile. Now you need to train the model. Now you need to train the model. How we will train the model? So if you want to train the model, you have to call a function model.fit. Model.compile to compile the model to tell which loss function, which optimizer, which metric you want to use. But model.fit can be used to train the model. You no need to write anything. Till now we write the code. We are just calling the functions. That's it. We are not writing any code. This is the very single line of information. Observe, this is a single line of information only. This single line is equal to your complete algorithm, that what we discussed. The single line is equal to that complete algorithm, that what we discussed. And this single line is equal to the complete code what we wrote here. This part, and backward pass, and this part. So all the things will be covered with a single line. That is the advantage of using the libraries, like a Keras library benefits. These are the benefits of using the Keras library. So if you want to train the model, no need to write the lines of code. Simply call model.fit, pass your training input and pass your training output. Batch size nothing but batch size 1 means in the training data you have the multiple data samples, right? Batch size 1 means pass the first sample, update the weights. Pass the second sample, update the weights. Pass the third sample, update the weights. That's what we did in the earlier also. That is the batch size 1. If you kept batch size equal 10 means pass the 10 samples at a time, update the weights. Later another set of 10 samples and update it. And later send the another sample 10 samples and update it. That means by 10. Or you keep 1, that means sample by sample the weights will be updated. Here epochs means max the number of iterations. Max the number of iterations, I want to keep it as 100. And verbose is nothing but the how you want to display this information. How you want to display this information, that is the verbose. If you keep verbose equal to 0, I will keep verbose equal to 0 first. And see how the model will be trained and how the output will be displayed. When I am getting the verbose equal to 0, nothing is displaying here. You can see. Done. So that's it. Training was completed, right? But what happened if verbose equal to 1 means it will display some information while training. You can see. So first epoch, out of 1689 samples completed. Now second epoch, again, so all samples are completed, then one iteration is complete. That means the number of samples in the training data is 1689. So this is my mean square error. Error matrix, we are using the mean square error, right? These are mean square error values. That's training was completed. Once the training was completed, what we did? We can evaluate the model on the test data. You have to pass the test data, input data and output data, and identify the mean square error, testing mean square error. If you want to calculate the testing mean square error, you have to use model.evaluate, pass your test input and also pass your test data output. Then it will give your testing error, testing mean square error. Actually, for that purpose, we are writing some code earlier. To calculate the errors, we are writing some code, right? You can see. So this is the code I have written, and this is the code also I have written to calculate the error. But here simply use model.evaluate. It will give the model.evaluate. It will give the your test loss values. So what the test loss value? 0.01589. Like that we can change. Okay. So this is how we can build our ANN model or artificial neural network model. See, I am doing some more modifications in the code. This is the code what we are using. Now, anyone can you respond? If you observe this code, tell me how many number of neurons in the input layer, how many number of hidden layers are there, and how many number of neurons are there in each hidden layer, and how many number of neurons are there in the output layer. Just see this code and anyone can tell me my questions. My question is, by seeing this code, so this is the code I want to keep. So please respond. This is the code, right? As per this code, my questions are number of input neurons, number of hidden layers, number of neurons in each hidden layer, number of neurons in output layer. So please respond for these 4 questions. See this code properly and give the answer for these 4 questions. Anyone, please. You can use chat box also. I will wait for 2 minutes. No? Anyone responded? No. That's why I want to close this session as early as possible. So Coming to this case, number of input neurons is nothing but this part. So number of input neurons are 6. Number of hidden layers are, you can see, so this is the input. On this input, you have the one layer, that is called a one dense layer, 1. On this one more layer, that is the plus 1. On this one more layer, that is the plus 1. See, input, right? So this is my input layer. On the input layer, I have the 132 dense layer. This is the 32 dense layer. On the 32, you have the another 32 dense layer. On the 32, you have the another 32 dense layer. On the 32, you have the one more layer with the one neuron. So definitely, this first one is called as input, and last one is called as the output layer. So last one is called as the output layer. So number of neurons in the last one equal to only 1. So it's the 1. Now question is number of hidden layers. So this is the input layer, this is the output layer. Whatever in between, those are called as hidden layers. So hidden layers equal to 3. 1, 2, 3 hidden layers. And number of neurons in every hidden layer, if you observe here, number of neurons in every hidden layer, that is the 32. That is the 32. You have to identify like this. And in the first hidden layer, I am using the tan hyperbolic characteristic function. Second hidden layer, I am using the tan hyperbolic characteristic function. And third hidden layer also, I am using the tan hyperbolic characteristic function. Here, and here, I am using the tan h hyperbolic characteristic tan h function. And whereas in the dense one, that means last layer, so I am using the sigmoid activation function. Here, I am using the sigmoid activation function. Like this, we can build the ANN model. Like this, we can build the ANN model. Suppose someone asks you, what are the total number of model parameters? This is the, wait. Well, yeah. So this is the one, second layer, third layer, fourth layer, and fifth layer, right? So now it's asking the model parameters. Model parameters means what are the weights between the first layer, second layer, what are the weight between the second layer, third layer, what are the weight between the third layer, fourth layer, what are the weight between the fourth layer and fifth layer. Similarly, what is the bias at the second layer, that is the hidden layer, third layer, hidden layer, fourth layer, hidden layer, and fifth layer, that is the output layer. That we have to calculate. So your W12 equal to the weights between the weights between your input layer and hidden layer. Here you have the 6 neurons. Here you have the 32 neurons. The weights are 6 into 32. That's equal to 12, 192. Okay. And what about the W23 between these two? That is the 32 and 32. So you can write 32 multiplied by 32. What about the W34, 3 and 4 between these two? Again, it is a 32 cross 32. And 4, 5 between 4 and 5. It is a 32 cross only 1. And what about the B2? Number of bias parameters in the second layer? Because 32 neurons are there, 32 bias parameter. B3 also 32 neurons are there, 32 bias parameter. B4 also 32 neurons are 32 bias parameters are there. B5, that the last layer has a 1 neuron, so only 1 parameter. If you add all, that is called the total number of model parameters. If you want, you can calculate. How? (32 cross 32). So 1024, and it is also 1024, and it is a 32. Now you can add all. So 192 plus 1024 plus 1024 plus 32 plus 32 plus 32 plus 32 plus 1. So total 2369 parameters are there. If you observe, you can see the same value in our code also. You can observe, if you run this cell, you can observe the same number of model parameters, 2609, 2369. Here also we are getting 2369. And how much space it is occupied? Memory space 9.25 KB. As the size of your ANN model increases, then the memory space also increases. Okay, so this is all about the implementation of the ANN model with the Keras library. And the last topic is how we will use the ANN model for the clustering problem that we will discuss now. So ANN for clustering problem. Okay. So actually, in real time, we have the three types of problems. One is called the regression problem and a classification problem and a clustering problem. I don't want to discuss about the classification problem, already yesterday discussed. Regression problem means in your problem, you are trying to predict one variable. If that variable is a continuous number, then that problem is called as a regression problem. Understood now? In your problem, in your project, if you are trying to predict one variable, which is continuous format, like temperature. Let's assume you are trying to predict the temperature. Your temperature may be 39 degree, 49 degree, 42 degree, 43 degree, 35 degree, 27 degree, any value. That is the example for the regression problem. Whereas clustering means you have the some data samples. Let us assume you have the some data samples. You have the some data samples like this. You have the some data samples like this. Now, clustering problem is you have to divide these samples based on the similarity. That means all the red samples will be one cluster and all these purple color samples are the another cluster. So that is called as a clustering problem. Clustering problem is you have a unstructured data, you have to make it a structure, or you have a different types of data, you want to divide the data into the different groups or different clusters. Different groups are different clusters. So that is the clustering problem. In the clustering problem, you don't have the target variables. You have the only input features. And these input features, based on the similarity between the one input feature to the another input feature, you are dividing the all the input features into the multiple baskets or the multiple buckets or the multiple clusters. So that is called the clustering problem. So clustering problem is simply I say that clustering problem is nothing but the grouping the all the input features of your data set based on the similarity that exists. That is called the clustering problem. Once again, I will repeat, clustering problem is nothing but the grouping of all the data samples of your data, all the input features of your data set based on the similarity between each other into the multiple groups. So that is called as the clustering problem. Okay. So in clustering problem, how ANN can be used? Let's assume I have the three input features A, B, C, and I have the multiple samples like this. Okay, I have the multiple samples like this. My goal is I want to cluster, I want to divide all these samples into the two groups or two clusters. I want to divide all these samples into multiple groups or the multiple groups we want to divide. Multiple clusters we want to divide. Okay. So how many groups? Just I want to divide the whole samples. Let's assume I have the 1,000 samples. All these 1,000 samples I want to divide into two baskets or two clusters. So this is my C1 cluster 1. This is my C2 cluster 2. This is my task. I want to divide the whole data set into the two groups, cluster 1 and cluster 2. This is what I want to do. How we can build the ANN model for this type of task? So to build the ANN model for this type of task, what you have to do is first you have to decide your input layer. Your input layer, number of neurons in the input layer equal to number of features in your data set. What are the number of features in the data set? 1, 2, and 3. So the number of neurons in the input layer equal to 3 neurons. So first neuron A feature, second neuron B feature, third neuron C feature. Okay. And coming to the output layer, the number of neurons in the output layer is equal to the number of clusters you want. How many clusters you want, how many groups you want to divide. I want to divide into the two clusters so that my neurons will be 2 neurons. So this is called as the cluster 1 and this is called as the cluster 2. And it is a completely fully connected as we discussed earlier. It is a completely fully connected like this. Like this. So again, as usual, you have the weights W11, W12, W21, W22, W31, W32. You have. Okay. Now, so that means my weight matrix equal to like this W11, W12, W13, W21, W22, and W23. Okay. Now, what we will do? So the process is first you pass the sample to your model. Step 1 is you have to take the sample that pass one sample to your model. And step 2 is calculate output. So output equal to how we can calculate the output? Your weight matrix, output Y equal to W weight matrix into your inputs A, B, C. Your output has the two outputs that is called as the C1 and C2, right? Because if you observe here, your size of this weight matrix is 2 rows and 3 columns, and the shape of your this input vector is 3 rows and 1 column. So you have the 2 rows and 1 column. So after multiplication, you have the output like this, right? That means you have the one value C1 here and the value C2 here. Now what we have to do is among C1 and C2, which value will be high? You have to identify. So among the C1 and C2, which value is high? You have to identify. Okay. So you have to identify. Let's assume C1 is a high value. Let's assume C1 value equal to 4 and C2 value equal to 2. Then which is one will be high? C1 is value is high, right? Now you have to update. You have to update only the weights connected to C1. Update weights connected to C1. Just update weights connected to C1. So what are the weights connected to first neuron? Delta W1 equal to, so how we calculate? That is the eta formula, eta into your inputs, that is the A, B, C multiplied by your corresponding weights. What is the weight here? Earlier weight, what is this weight? W11. What about this weight? W21. What about this weight? W31. So like that, you can calculate the delta W, change in weight. Once you got the change in weight for all the paths connected to the first neuron, now update the weight W1 equal to W1 plus delta W1. That's it. So out of which only you have to update the weights connected to your winning neuron. This is called the winning neuron strategy. How we identify the winning neuron strategy? That is depending upon the first to multiply your weight parameters with a matrix ABC inputs and calculate the outputs, and whatever the output is high, that neuron will be considered as a winning neuron. And you have to calculate the change in weights connected to that winning neuron and update the weights. So this is the what we are using in for the clustering problems. So this type of learning algorithm is called as the competitive learning algorithm. Competitive learning algorithm. Why it is called as a competitive learning algorithm? Because it is a competition between the neuron 1 and neuron 2. There is a competition between the neuron 1 and neuron 2, which will be the high value, that will be the winner, and remaining one is the loser. And who is the winner? And the weights connected to that winner neuron only updated, remaining will not update. Remaining will not update. So this is the process for the competitive learning. So now we will see the coding part also. After that, we will stop this session. Clustering problems. I shared the complete thing for you to deliver all the sessions, but as the response from the participant is not up to the mark. If you responded positively, if you interactively participated, if you ask some questions, then if you respond, then it will be very interesting. But I'm not seeing very less response from the other side. I think Mronalini and one person is called TM, and only few are responded. Okay. So here my task is, my application here is, I collected load on SR University from the classrooms meter and from the hostel block electrical meter and also from the lab electrical meters. Understood now? I am collecting the load data from the labs, from the hostel, from the classroom. That load data is displayed here. 3 megawatt, 0.3 megawatt, 0.1 megawatt, 0.5 megawatt, 0.4 megawatt, 0.2 megawatt, like this. 3 megawatt means in a hostel at a particular day, 3 megawatt of power is consumed. And in the classroom, 0.3 megawatt only consumed, lab 0.1 also consumed. Whereas in this case, third sample, 0.3 megawatt consumed in the hostel, and whereas 3 megawatt in the classroom, 4 megawatt in the lab. So this is the data I have. There is no outputs, only inputs I have. Here my question is, I want to split this data. I want to split this whole data like a working day and weekend day. That means working day load patterns will be separated and weekday load patterns will be separated. I want to do that one. I want to cluster the complete all the load patterns into the two groups. One group is the working day loads, another group is a non-working day groups or weekend groups. I have the some load data samples, right? I want to divide these load samples into two buckets, two clusters. One cluster is like a weekend load samples. Another cluster is like a weekday load samples. As usual, this is my, I want to import the data from my Google Drive. In this path, my clustering example data is available. I'm importing the data and I want to split the data, train to test split method, splitting the data. As usual, so because if you observe our model, 3 input neurons and 2 output neurons. So my matrix size is 3 by 2. So I am randomly initializing the weight matrix 3, 2. 3 inputs and 2 outputs. So random initialization of the weights. And this is the algorithm for my computative learning. This is the algorithm for my computative learning. The computative learning, what I'm doing here is, this is my epochs loop. This is my training data samples loop. Here, what I am doing, I am calculating the output. How we calculate the output? How we calculate the output? Output when we calculate it based on the weight into input, right? That's what I'm doing. This is the input and these are the weights. So weights into inputs will give the output. It will give the output C1 and C2. And out of outputs, which will be the maximum? Either C1 is maximum or C2 will be maximum. So to take that maximum, we have to use np.argmax. In Z, we have the C1 and C2. But I want to identify the winning neuron, which has the highest value, which has the maximum value. That's why I'm calling np.argmax of Z. np.argmax of Z. Then it will give the winning neuron, whether it is a 0th neuron or neuron 1. 0th neuron means first neuron called as a 0th neuron and second neuron is called as a neuron 1. Indexing will be start from 0. Index 0 neuron means first neuron. Index 1 neuron means second neuron. Now what we have to do? We have to calculate the delta W. Delta W equal to eta into your input data minus, you have to take the weights corresponding to the winning neuron. So winning neuron is C, right? So you have to take the weights corresponding to the winning neuron. That will give the change in weights. Once you got the change in weight, simply update the weights connected to the winning neuron only, not all. That's why weights of C equal to weights of C plus this delta W. So this is the complete process. Okay. Now this is for the prediction. Now I want to give training was completed. Now for this model, I'm giving the whole data. Now how it will be splitted, you can see here. So I'm giving the whole data. Now it is splitted. It's saying that first sample is a non-working day. Where is the samples? Otherwise, we will do one thing. Data, right? Data. I think I have only 6 samples. Okay. This is my data. This is my data, right? You can see here properly. First day, hostel 3 megawatt, classroom 0.3 megawatt and lab 0.1 megawatt. So generally, this type of pattern will be exist in weekend, because weekend classes will not work and labs also will not work. So this consumption is less and the hostel will be more. That's why first sample should be non-working. Now you can see the output here. So first sample is a non-working. Second sample, again hostel 5, 0.4 and 0.2. It should be non-working, but still my model represented the working day. That means my model is not perfect because even it is a non-working day, but it is showing as a working day. Third sample, it is a 4, 0.5 and 0.1. By seeing this pattern, we can easily say that it is also non-working day and third also non-working day. That's fine. And next one, 0.3, 3 and 5. Hostel is 0.3 megawatt. Classroom 3 and lab 4. This is called the working day. So working day. And this is the 0.4, 5 and 6. This is also working day. So that is the working day. So like that we can cluster, we can divide our samples into 2 clusters, working day sample and the weekend samples. Right? Hope you understand how we are dividing the data. Right? So this is all from this FDP, and I shared this complete Google, this GitHub file already shared with you. You can do more practice. If you have any questions, please ask.